So let's see what we will be doing today. So let's grab as an example our game, the Star Wars Galactic Battlegrounds. So when you release the mouse, you select a single unit. Now if you shift select another unit, you're going to keep adding to the current selection. However, if you select a unit that is already selected, you're going to deselect that unit. So that is how it works. So if you select with shift, it's going to deselect them or add them to selection. So that is what we're going to achieve inside Godot, which I'll be calling as selection operations. So let's go ahead and see how we can do that inside Godot. So now let's talk about how we are going to implement their RTS selection operations. So what exactly we want? We want a drag box selection plus a mouse release to select these units that are inside the drag box. We also want that same behavior, but when you use shift, we want to add these units to the current selection. We also want a single mouse release to select a single unit, and if you press shift, we want to add or remove that unit from the selection. So how are we going to do that? Well, the first thing is understanding what the selection variable is going to be, which is an array. So here are some array functions, which is going to be very handy for us. This is what they do. And here's an example of what an array looks like. So you're going to have all your units inside the array just like that. So let's see some functions we are going to be using in order to make everything that we talked about happening. We are going to need some selection add functions to add a single unit and an array of units. So the first one is to add a single unit to the current selection. The second one is to add a group of units to the current selection, and we're going to append the units from that array we give as our argument to the function. So now we need some remove functions for our selection. We're going to use a single one, so to remove a single unit, and we also are going to be using an array, so we are going to remove units from the current selection, multiple units. So we also have three new functions here that we're going to use to help us. The first one is the toggle select unit, which is going to iterate through the selection and add or remove that unit based if it's selected or not. The second one is we have to select a couple of units through an array. So we're going to replace the selection with a given array, and this is fairly useful if you want to make group style RTS. So like you press Ctrl 1 and you'll have assign a group. So this is the function you can use to make that happen. And finally you have a selection clear function, which is basically going to clear the current selection. So all of those functions are going to be used to make all the behaviors we talked about in this video already. So another thing I want to talk about is how you're going to implement the selection methods. So for the direct box selection, I made a previous video. If you want to see it, check it out, and explain in further details how to implement a direct box selection inside Godot. So basically on the mouse release, you're going to select units that are inside a rectangle box. But we also need to make some method to single select some units. So one of the ways you can do it is to cast an array from the camera against a sphere collision area for the units, and if the array collides with it, you can say it's selected. However, I'm going to be using a little different method, which is use the unit's position as vector 2 and select them if they are close enough to the mouse position. This is a little faster, however, this is not 100% accurate. I will be implementing in this video the second method, which is to use the unit position as vector 2. So let's talk about selection optimization here. So what I did on the previous video where I implemented drag box selection method is to have a selectable units area filter, which is an area 3D that follows the camera, which is going to allow units inside that area to be selected. This avoids running functions for the units of the entire map. So if you think about it, you have a big map inside Godot and you want to select a couple of units using the drag box selection or the single select. One of the ways that I excluded all the other units that are not visible to the camera is using that area 3D, which basically reports and keeps a list of all the collided bodies that are inside of it. And these are the selectable units, which you can select through the mouse selection. So this is a optimization I did on the previous video. So that is all we have to do on this video, and let's see how we're going to be making this inside Godot. So let's hop in Godot. So back here on our project where last left off, let's change some things before start to implement the selection methods. So one of the things I want to change is to fix this issue here, which was a temporary solution to allow our units to not overlap with the ground. So let's push this unit back to where it belongs, up top on the floor, and let's fix why we had to do that. So let me hide the unit graphics, and let's see our raycast. So the issue was that our units were overlapping with the ground terrain, and the reason for that is because the raycast starting position is at the feet of the unit. So there's quite a space there that collision errors happen, and this made the raycast through the terrain. So one of the ways we can fix that is just by pushing our raycast upwards. So now our raycast is going to be casted from the top of the unit to the bottom, and this will fix the issue we had earlier with the units crossing terrain. And we can also go back here to our code and on the physics process remove this bit of code here, which was to make the unit float a little bit above the raycast collision points. Now with the raycast already floating, we'll get rid of that issue. And because you lift the raycast a little bit, you're going to also need to increase the target position so the raycast can actually reach the ground. So if we put -3 here, you can see the blue being raycast, which is this blue thing here, is going to be stretched a little more downwards so it can help us with detecting the ground. So now your unit graphics can stay above ground just like any standard graphic, and we don't need that anymore. However, here comes another issue, and to illustrate the issue, I'm going to make some changes here. One of the changes that I want to do here, so you can see what I'm talking about, let's move our raycast a little bit forwards, so just like here, so you can actually see it. So the issue that I am having is the following. Our raycast is colliding with the collision mask 1, but our characters are on collision 4, so it should not detect our characters at all. But our characters can detect mask 1. So mask 1 is because terrains are on layer 1. So mask is what you can detect and layer is where you belong. And you can belong to multiple layers at the same time. So the issue I'm having here, and I don't know why that is happening, is that our raycast is detecting other character bodies 3D despite not being the collision mask, while the character body 3D is on layer 4. So this should not be happening, but it is. So when we run our scene, remember that units are playing on the layer 4. So units belong to layer 4 and our raycast is colliding with layer 1. However, when we move our units, you can see this is happening, and I don't know why that is the case. So what is going on is that the raycast that we made for terrain is actually collided with other units. And because our collision shape is lifted above the ground, it's teleporting ever so slightly upwards until it starts to fly off. So this should not be happening because the collision of the raycast is on layer 1. So it can collide with terrains by default, because our terrains use static body 3D, which has by default layer 1. So they should not be colliding with our characters. And you can see that this is the case, because if I change the raycast collision mask to something else like 2, you can see it is not going to detect the other units anymore. So the issue is on collision layer 1, and I don't know why that is the case. So let me deactivate our navigation debug here from navigation agent so we can see stuff. And let's run our scene again. So you can see that now the raycast is not colliding with anything else. And if we go back here to our units and place them back at collision mask 1, they should not collide with our units. Again, our units belong to layer 4. Yes, our units are colliding with the mask 1, but that doesn't mean that other units can detect it. If you disable this, you can see that the issue still persists. There are 2 solutions for this, and I'm going to show you how you can deal with this. So you can see the raycast is still colliding with the other units, while it should not to. And I don't know exactly why that is the case. I have to do more investigation. Maybe this is a bug. But so one of the solutions is to move all terrains to have a different collision layer than the default one. So let's open here our navigation region, go back to our terrain. So on the static body collider, you can see that it belongs on layer 1. Set our collisions to layer 2. So now our terrains only belong to collision layer 2. So now if we go back here and we change our collision selection mask to number 2, which is only terrains, you can see that now the issue is fixed and the units no longer collide with other units, the raycast that is, but it collides with the terrain alright. What you can do here is also set our characters to collide with layer 2, because layer 2 belongs to our map static colliders, so now it can collide with the terrains as well. So this is not desirable, because layer 1 is the default layer for any static colliders you create on your scene. So if you import any 3D meshes from Blender with static colliders, you're going to have to set up manually for all of them through an import script or something, so you can deal with these issues for usability. So let's run our scene here, and you can see that the fix works. Our raycast no longer collides with other units, but we are still colliding with the terrain altogether. Now we have to revert back our raycast to be on the center of the unit. So on the transform position, let's place it back here, and let's increase its Y position a little bit so it doesn't collide below the terrain. We can actually put 1 here just to make it safer. So that solves 2 issues we had, and that other issue of the units teleporting I didn't even notice, to be frankly. I just after testing saw that. So that's about our unit here. So I hope I made everything clear here. We had some issues when the collision of the raycast, because the raycast, despite being marked on collision 1, was colliding with other units that did not belong on collision 1. So this is something to keep an eye at. So now let's address our selection methods. So this is a side project that I'm doing in parallel with our tutorial project. And as you can see, this is what we are going to be achieving today. So you can select units, you can tell them to move somewhere, and it's going to play an animation with some sprite 3Ds. And if you hold shift and select, then you can add selection to them, and if you single select a unit, you can move it. So you can see it's starting to look like a game now. Great, so this is what we are going to achieve. So first thing, let's start by creating an input to the right mouse click position. So let's create an input for the mouse right click. So let's go to input map, and I don't think I created one for the right mouse button. It is used for camera rotate, but I would like to change this. So currently right mouse button is used for camera rotate. So let's change this a bit. Let's use Alt right mouse click to rotate the camera, and we can change this later. This is just for now, so we don't have to change the input, the action camera rotate. So let's create here a new one, which is going to be mouse right click, and I'm going to be keep it the same name as the other one. And the same thing, let's just add here a right mouse button. So now we have our right mouse click, which is going to use for our selection operations to move our units. So let's save our scene here, and let's enter a little bit of code. So one of the things I want is to create a variable here for our units. So let's go to our test unit. Let me see if we have it. So we actually need a variable called selected. So we know that the unit is actually selected. So now we have an issue, and that is because we have functions with the same name as the variables. So let's actually delete this, and I'm going to be changing some stuff here. And you can also delete this line here. We're going to set up something here that when we change the selected variable, we're going to call a function. So let's go ahead, and so we are going to actually use here setGet. If you used Godot previously, that is the function for 4.0. So what we are going to do is whenever this variable changes, we want to execute something else. So you do that by opening this here, and you say set new value, and this can be whatever the name. This just represents when you change the variable that is going to be stored here. So this right here is when you change the variable, this is what is going to be stored at. So then we're going to say that selected is equal new value. So that is by default the standard way you set variables. So this should be always set. But we're going to call another function here, and this is the additional function we want. So let's call here unit, let's call update selected. So we don't have this function, so let's go ahead and make it. So I'm going to be going below our main functions, and I'm going to be called like that and this. If we are selected, then we're going to show our sprites. So I don't think we actually have it. So let's go back to our unit, and let's add our selected here. as a node. So let's go to our nodes here. And so now we actually have our 3D sprite node here as SPR selected. So we're going to display our SPR selected if we are selected. Otherwise, we are going to simply say .hide. So what this is going to do is whenever we change the selected variable, it's going to ask what we want to do with that new variable you set in. So whenever you change the selected, it's going to update the selected variable and it's going to also call another function. So this is quite handy. And now we just need to change the selected variable to update our selection here. And because we are setting our selection as false by default when we run our game, our units should not display the selection despite it being visible, which is the case here. So we still need to do that. So let's go back to our unit and let's add selected equals false. So we're going to leave the selected right there. So now as you can see, the units are deselected just by changing the selected variable here on ready. So that's one of the ways we can update our selection sprites. So I just added back here to my project some images here. And if I double click, you can see this is just some sprites for me to change the selection because it's frankly quite ugly. This blue square. So let me just update with new graphics, and because this is a little big, we have to change here the size, and I think this is actually good. Now I'm going to put it as white and give all the transparency it needs. Let's make it a little smaller. I think that looks okay-ish. Another thing, I'm going to place it back on the center because it's floating a little bit. But because this is a sprite, it's going to fight the z-depth of the terrain. So let's place it a little above so it doesn't clip on the terrain when it's teleported on the ground. So now it's actually going to show. So now our selected sprite is a little different and a little better. So now let's actually change how the units move. So the units are moving on the input of the units themselves. So we do not want this. So let's delete this function here and let's translate this to our player interface. So we want our player interface to detect the input and to tell our units which are selected to move to the position we want. So let's go to our player interface and we are going to see we have an input here. So we are going to need to be translating this function back to here. And we're going to make some changes. So let's go to our play interface and starting changing some stuff here. So one of them is we need to store our selection. So currently we only have a box selection of units. So units that are selectable. We need an array to store our current selection. So let's create a new variable here. So we'll be using this variable here to store our current selection. So here on the input of our player interface, we are going to be checking if we release the mouse left click. If that is the case, we want to know if we are creating a drag box or if we are single selecting our units. And we can check this by checking the drag rectangle area, which is that square of selection. So we are checking its size, length squared, if it's higher than our minimum drag squared, which is simply a constant of 1/28. So if that is the case, we're going to be casting a drag selection. However, if that is not the case, then we are single selection mode. And we're going to be creating a new function here, which is going to be a selection single cast. So this is just for standard naming. So let's create this new function. Something we also are going to need is to create a shift action so we can check it later with our selection. So let's go to our input map and let's add a shift action, which is going to only hold our shift press down. So now we can actually use this for our action code here. So what I'm doing here on the input function is the following. We are going to be checking for if our action shift is pressed and give it the result of that as a Boolean variable. And we are going to pass that Boolean variable to our selection methods. So here is the selection for the drag box selection mode. And we pass that shift Boolean here as well. And we also pass that to our single selection cast. And we pass the mouse position and the shift. So what exactly are single selection cast do? So here we have some functions. So let me go through them first. So if you remember, we had some functions we were going to need in order to make the selection. The selection add is going to add a single unit to the selection array and is going to tell that unit that it is selected. The selection add array, on the other hand, is going to add units to the selection. And the way it's going to do this is going to iterate for all the units that we want to add. And if our selection does not have them, we are going to add them using the selection add function. For the remove functions, we have the selection remove to remove a single unit. So the way that the selection remove function works is we give an I value here, an integer at 0. For each unit in the selection, we are going to do the if here, and we're going to add another I. So it's going to use to iterate through all the units in the selection. If the unit we want to remove is inside our selection, because we are using the I here to iterate, we can simply delete that entry from the array using the I, and this is going to remove that unit from our selection, and we just deselect it here. And because we found we are only remove a single unit, we simply break out of it. So here is almost the same thing for the selection remove array. The only difference is we double nest another check. So for each unit in the selection, we are checking for each unit we have inside the units to remove array. And if the unit that is in the selection is equal to the unit we want to remove, which is inside the units to remove array, then we're going to simply remove that array entry using the I iterator. And we also deselect the unit and break free from the second loop here. So there are two loops here. For each unit in the selection, we're checking for each unit inside the units to remove array. So this is a little more expensive than this one. Then the next one we want to have is the selection toggle select, which checks for single units. So what we want to check if that unit is selected. If it is selected, then we want to remove that unit from the selection. And if the unit is not selected, we want to add it to the selection. So this is quite simple. The selection select array is going to first clear all the selection, then it's going to iterate for each unit inside the units to select. If those units are not selected, then we're going to append them to selection and make them selected. And if they are, however, already selected, then we're going simply to toggle. So this is almost like a toggle selection, however, for the entire units array. Finally, for the selection clear, we are simply checking for units inside the selection, deselect them, and clear the selection array. So these are the functions that we talked about on our presentation and how they work. The selection drag box cast selection now uses a shift enabled boolean argument. So if we are not using shift, automatically we are going to clear the selection. So when you hold and drag to create a selection box, if you're not using shift, we are going to remove all the units already selected, then select some new ones. But if you are using shift, then you're going to simply add them to the selection. So this is how it is working. And this is how we select units inside the drag box rectangle. Details on the video I talked about how to make the selection drag box. So the function that selects a single unit uses a mouse 2D position, vector2, and a shift variable here. So for each unit in the selected units array, we're going to first grab their 2D position by unproject their position to our current player camera. And this right here allows for auto-completion, so just for us to have automatic here. So this assures us that unit is a node 2D. Then we're going to grab their transform origin. So this is how you're going to grab their position. And because our origin for the units are on the feet, when we select units, you usually select their center. So somewhere right over here, you don't select units by clicking here. So one of the ways that I fixed that was to add a offset vector 3 on the Y position. So instead of you having to select here, you can select up here. So the check for the selection distance is going to be calculated from the center of the units right here. So if you make bigger units, you can increase the size range, and you can also offset the pivot to wherever you want. So that is how I am achieving that here. So if the mouse 2D position, the distance to our unit 2D position is less than a given here, and we can change this to be more or less precise. So let's put something like 30. This is on pixel values distance. So 2D coordinates are based on pixel and 3D coordinates are based on meter. So 1 in 3D coordinates is like 1 meter. And in 2D coordinates, 1 is a single pixel, so in relation to 3D, it's very small. So this is actually for the vector 2, which is pixel distance. So we are checking if our mouse position distance to our unit 2D position is less than 30. If that is the case, if we are using shift, we only are going to add that unit to our selection and return and skip this loop right here and the function itself. However, if you are not using shift, we are going to select that single unit. And here I'm actually using the select array to give an array with a single unit. So it's only going to select that unit and skip the function. However, if any of those conditions did not happen, we are going to come here and simply clear the selection. So if you click somewhere to select a single unit and you didn't find any units that have their position close to the mouse, we're going to simply clear the selection. And another thing I'm going to be adding here is, I already created the code here. I'm going to be adding an animation player that's going to hold the graphics for our move function. So whenever we move, we want to display a sprite at the mouse position with some animation. And I'm going to be adding this inside our player interface node here. So let's create a new node, and this one is going to be UI order. So this is our animatable UI order. And I'm going to add some sprites here. And you can actually move this out of the collision avoidance point. So let's add an animation player here. So let's add some graphics here to our sprites, and I'm going to be adding a simple, let's see what this one is. So I want two guys, I want this and this guy here. So I'm going to be creating a UI order graphic using these two sprites. So let's put them on the Y coordinates, and because they are going to be fighting ZDef, you're going to be increasing a little bit. So let's increase the Y position to something like 0.08. And for our animation here is going to be something very simple. So it's our move order. What we want is to grab the sprite modulation, so we can animate their transparency. So with the sprites here, I just animated their modulation here. And if you play the animation, you can see what it does. And the name of the animation is move order. So now that you have this element here as a node 3D, our player interface can save that. So let me minimize the animation. Our player interface can now save that as a node, and we can use this whenever we go to our input function of our player interface node. So we're going to be checking for a mouse right click, and if our selection is not empty, we are going to play some animation here. So we are playing the animation we just made, and this stop here is to reset the animation back at frame 0. Otherwise, it's going to, if you press multiple times, it's not going to reset the animation. And we simply get our animation player, the parent. So you're going to grab the UI order nodes, and we are going to place this on where the mouse is actually placed. And as you can see here on the camera, raycast coordinates. So just like the previous video, we projected a raycast, and this is how it works. If our position to the raycast is valid, then for each unit inside your selection, if that unit has a move unit function, we're going to simply move that unit to the camera raycast coordinates. So if we go back to our unit here, let's create a move order function. So this is going to be very simple. So this is how the unit now actually moves. Our move unit function is going to reset the stack count. This is related to the previous video. We are randomizing a little bit the movement of the unit, so just like the previous video, and we assign a new movement goal, and we are going to simply say to set its target position. And this is actually wrong here. This is supposed to be our navigation path timer, so this is a typo here. So the timeout for navigation is going to be emit the navpath timer updates, which we connected. So you can see here when our navpath timer times out, it's going to call that function, which is basically updating the navigation. So this is all related to a previous video. So with this, now we should be able to make our units move. So if we run our scene here, you can select the units, right click to move it, and we'll play the animation with the UI order node we just made. And that is how you make the selection for the units. So this project has broke continuity on this video, because if you're watching just this video, there are a lot of things that are happening at the same time, which I cannot explain because this would require me to explain everything that I already did on previous tutorials. So hopefully by breaking down each function, you can understand exactly what I did to achieve these results. So if you didn't understand something that I explained here, please check the previous video. And sorry if this video has made a little more complex than the previous video. I'll try to make things simple, things get complicated. And as the project grows, things will be starting to get more and more complex. So hopefully by breaking down the functions, you could understand everything that I did. So this video was addressed through the selection operations. But you can see that this project had a lot of stuff that I worked and improved behind the scenes here. And I cannot show everything because this will turn the video to be too long. Maybe you are interested in that. I'll see you what I can do in the future. But for now, hopefully I was able to help you or inspire you to make your own RTS selection modes in Godot. So thank you all everyone, and hopefully you enjoyed the video. Leave a like if you liked the video, post a comment if you have any questions, and I'll try my best to help you. So thank you guys for watching. I'll see you on the next one.